Hey guys, Ms. Davis here again. We are going through Unit 5, Skill 7, Part B, which is how can we solve for a missing side or sides of right triangles in a word problem. So now we're going to look at some real world situations and apply what we've learned so far about right triangle similarity. So let's go ahead and take a look at the first example. A 24-foot ladder leans up against a house. So as we can see, there's our 24-foot ladder leaning up against the house, that line, that hypotenuse there. A brace is used to support the ladder, and where the brace meets the ladder is 10 feet from the base of the ladder. So right here to here is 10 feet. So luckily they've already drawn in the numbers for you. You don't have to do any drawing. You just have to now find the length of the brace to the nearest tenth of a foot. Okay, so we're finding this distance right here is the actual brace. So remember what we did last time, and we have been doing this unit, is separating and redrawing the three triangles when we have this crazy picture. So I'm going to make a little asterisk off to the side. Remember, if I could remember how to spell remember, to separate and redraw the three right triangles. Okay, so looking at our diagram, I'm going to go ahead and, you see that red one that I just highlighted there. I'm going to flip that around and draw it over here. So we've got the right angle here, right there, the 10 feet on the bottom, and the X on the side there. Do we know the hypotenuse of that triangle? Nope, we don't know that one. So I'm going to go on and make another, let's see, that's the smallest triangle. Now the biggest triangle would be this one here. So this big one I'll do in blue. So when I redraw that one over here, I've got like that, and I got 24 as the hypotenuse. Do I know any of the other two blue sides? No, I do not. So now my last triangle that I'm going to highlight here is this one from here to here to there, that green triangle. And if I look at the numbers on the side here, I got 24 right here as a hypotenuse and 10 right here, then I can actually label from here to here after I do subtraction. So I'm going to do 24 minus 10, giving me that this remaining distance in here is actually 14, because if you add 14 plus 10, that gives you that 24 back. So I'm going to go ahead and redraw that triangle, that green one, over here. So here's the green one. Okay, so the green one is going to have, this is our long, tall side, so that's going to go 14 over here. And then our X is going to be that base, so we're kind of like reflecting it and flipping it around. And once we have the three of them all separated out, the first question that we can ask ourselves is, can we use a squared plus b squared equals c squared to solve for x here? Well, which one can we get rid of right away? That doesn't even involve x at all. The blue triangle doesn't have any x, so there's no x, so we're obviously not going to use that triangle. So can I use the Pythagorean theorem on the red triangle or the green triangle to find the x? Well, in order to use Pythagorean theorem, we need to have 2 out of the 3 sides known with numbers, and we don't have that for either of them. So then our second step is to ask ourselves, can we set up a proportion? Which would be matching of the 2 sides, 2 pairs of corresponding sides to do that proportion piece. So this idea of fraction equals fraction. So looking at my diagram, you see how I've got small triangle over big triangle as one pair of sides I can set up. So x over 14 equals, now I could do 10 over x. So it would be left over right, or small triangle over big triangle, equals small triangle over big triangle. Just remember to go from small over big equals small over big. Okay, so now we were able to set up that proportion. Yes, and now we can cross multiply. So first thing I'm going to do is x times x. So it's going to be x squared equals 14 times 10. So 14 times 10 is 140. Let's see what they want us to round to here, because I know I'm going to square root both sides, and I'm going to end up with x equals, and that's not a perfect square, so we're going to get a decimal. So I need to see if they want us to break it down or round it. So round to the nearest tenth, which means we just plug this into the calculator. And when we do that, we get 11.8321. And again, the nearest tenth is the number right after the decimal. So we're rounding to 11.8 for this one. So x is equal to 11.8, which means that that brace that's supporting that letter here is 11.8 feet long. Okay? All right, next example, scroll on down. So we're looking at Joe, who needs to cut a new piece of wood to replace the beam that is currently holding up his roof. The length of the sides of his roof are 5.5 meters and 3.1. Again, everything is labeled here, while the width of his house is 6.3. Find to the nearest meter to the length of the support beam. Oh, sorry, of the length. There you go, of the support beam. So it looks like that's already labeled for us. So right here we've got the height of that support beam is measured as h. So what we need to do is take a look and separate and redraw these three triangles. So the first triangle, I'm going to redraw a highlight in green. So I've got z, y, x. Whoa, that's a bad line. So I'm going to redraw that one over here in green. So flip it around, redraw it. Right angle there. Our right angle is y, so we've got y. Our shortest side is down here. This is our shortest side. There's our long, tall side is going to be z up at the top. Okay? So our tall, long side is 5.5. What else do we know? We know the bottom side is 3.1. And we know that hypotenuse from here to here is 6.3. Okay, so there's one side, or one triangle drawn. Our next triangle we're going to redraw, I'll do in blue. So I've got the little small one in here. Okay, so I'll redraw that one over here in blue. Right angle, we've got, we don't know anything about the bottom of that right triangle, but we do know that the hypotenuse is 3.1, and we know that the height, that h there, is what we're solving for. And then our last one I will do in red, which is going to be this one here. Okay, so when I redraw that one around, boop, boop, boop. Don't really like that. I'm going to redo that again. Boop, boop. There we go. So our base of that one is our height, that h. We've got a right angle here, so that means that our hypotenuse, so it's going to be w down there, and y, and then our hypotenuse, be y, z up here, is going to be 5.5. Okay, so what we need to do now is we need to take a look at if we can set up or use the Pythagorean theorem to find the missing side. So on either of the red or the blue triangle, can we find the h, that height, the length of the support beam, using Pythagorean theorem? No, because we don't have two sides known. We only have one on each side. So then we have to go to proportion. So we're looking at how can we set up a proportion between the two triangles. So you could actually use the green and the blue, or you could use the green and the red, but we can't use the red and the blue together because those sides don't match up together. So I could do 5.5. Oops, that looks a little sloppy. So 5.5 matches up with the h here. So I could go big triangle over small, so that over that. And then I could also do this pair. The two hypotenuses are also given, so we could use those two as the second pair of corresponding sides over 3.1. Okay, so now go ahead and cross multiply. So 6.3h is equal to 5.5 times 3.1 is 17.05. And then divide both sides by 6.3. All right, so we end up with the height is 2.7. Okay, all right, go ahead and flip on over to the next side. I'm going to zoom in here. Okay, so it says use the picture below, find the distance across the pond. So first things first, let's label our X where we need it. So the length across the pond is going to be right here. So I need to go ahead and separate and redraw these three triangles because we've got that altitude drawn in. So I'll draw the big red one, or big one, medium, and small. Okay, so our right angles go there, there, and there. And what do we got? So our big right triangle here is going to be BCA. So I've got BC, our longest side of the big triangle. It's going to be X. Now our hypotenuse here of that right triangle is going to be 16 plus 9. It's actually going to be 25. So it's going to be 25 here. And then we don't know the base there. So we're rotating this to stand upright here. Okay, the middle triangle, we're going to look at, I'll do it in blue here. So the medium-sized triangle is going to be this one here. Messy. Right angle there. So our 16 is going to be that long, tall side, which is going to go over here. So 16. And then our base we don't know anything about, but we do know that our hypotenuse is going to be the pond distance, so X. And then our small baby triangle over here, this one here. Again, there's the right triangle. We don't know anything about the hypotenuse, but we do know that our base is going to be 9. Do we know anything about the height here? No, we have no information about that. So our distance that we're finding is across the pond, so X. Can we use Pythagorean theorem in any of these three triangles? Our answer should be no. So now we're moving on to a proportion. So we're going to have to set up some sort of proportion. The one we can eliminate here is definitely the third smallest triangle because we only know one side and it doesn't involve the X. So now we need to go ahead and set up those proportions. So I've got X over 16. That's one pair of corresponding sides. The two heights equals 25 over X. So 25 over X. All right, go ahead and cross multiply. So X times X is X squared equals 16 times 25 is 400. All right, square root both sides. We get X is equal to, what number times itself is 400? 20 times 20. So our answer is going to be X is equal to 20. So the distance across the pond, so distance across the pond is 20 meters. Okay, so the last part here says Bob believes that the distance from point C to D is at least 13 meters. So what does at least 13 meters means? It means 13 meters or more. Okay, so at least means that amount or greater. So we need to relook at our triangles now, and we can actually label that our pond is 20 here. So this is going to be equal to 20. So when I separate and redraw these triangles once more, so I'll kind of copy down this picture up here, down here. So I've got the big triangle. We now know that the distance on the pond is 20, and this is 25. Our medium-sized triangle was 16 and X, and then our small triangle was 9. And well, we also have to look at this middle triangle. The X we just found is actually 20. So we can go ahead and solve from here. Take a look. So from C to D, where is CD? CD is actually going to be, let's see, label on our diagram. CD is right here, that altitude. So it's actually going to be the distance on the small triangle there. And if we look at our blue triangle, the medium-sized one, it's also this distance down here. So, let me redraw that in there. So it's, the reason why I'm using y now is because we've already used x, so we need a different variable. So our y is going to be that distance on the small triangle and on the medium triangle after we redraw them. So, explain your answer. Is it at least 13? So we actually have to solve for it. So looking at our picture, can we use Pythagorean theorem on any of these three? Yes, we can. If you look at the middle triangle, see how we've got 2 out of the 3 sides? We could actually solve this middle triangle using, the Pythagorean theorem, or we could set up a proportion because we also have some information on our smaller triangle, the y and the 9, that we could also use. But I think the Pythagorean theorem is just a little bit easier, but either way it doesn't work, or it will work. So if I use the Pythagorean theorem, I can actually apply that this right here is our C, our hypotenuse, and this is our A and our B. So I'm going to go ahead and plug in our y squared as A plus 16 squared equals 20 squared. All right, so go ahead and simplify what 16 times 16 is going to be. So hang on, y squared plus 256 equals 400. Subtract 256. Y squared is going to be equal to 144. Square root, y is equal to 12. So the distance from C to D, so CD, is equal to 12. So to answer that question, is Bob correct? Is it at least 13 or more? No, he is not correct. No, because the distance is less than 13 meters. Okay, so there's the explanation piece. And again, you could have used a proportion for this one. So we could have set up 16 over y equals y over 9 using the small and the medium triangle. And if you did that, you would actually end up with the same thing as y is equal to 12. So multiple ways to do this problem. Okay, write your summary, give me a couple sentences there, and go ahead and try some practice problems.